Alrighty, here we are again with APCalendar, the demonstration. So on the first video of this two-part video or two-part solution here, we looked at the methods only at the methods whose implementation was not shown, and basically you're not responsible for these methods. You can just assume that they work as intended. So basically, they're telling you can use the method as leap year returns true if the year is a leap year, false otherwise. And you don't have to worry about how it does it. So like this that I wrote here, for example, would be a good implementation of this East leap year method. But they don't care about whether you know how it works. They just want you to understand how to use the method. So we spent time on that. I spent time on first day of year, which returns to you the first day of every year that you request. So for example, if you send it the year 2030, it would return to you the first day of that year in terms of what day in the week it lands, whether it's a Monday or a Tuesday or a Wednesday. Now I hard-coded these values 2000 to 2020. In theory, though, it says that the implementation is not shown, and in theory, it would work for any year. Right here, I can only test it for the years 20 to 2020 because I only coded those years. But in theory, it would work for any year. I looked up when the current leap year sequencing that we use, meaning every 4 years we introduce the 29th day in February. It started like in 15 something. So before that, the calendar was somewhat out of whack. Again, I'm not an expert, but I read, doing a little bit of research, that there was a year where they had to add like, I don't know, 20 days for at the end of the year to have the calendar year conform to the actual seasons of the year, which is what were the objective. The reason we add a leap year is so that summer always lands in, at least here in the Northern Hemisphere, anywhere like between June and September, and the fall always lands between September and December, and so on and so forth. If you don't add that year, that extra, I'm sorry, not year. If you don't add that extra day in February, eventually your seasons are not gonna agree with the calendar. So like maybe summer is no longer gonna be between June and September. Now summer is gonna be maybe between January and March eventually, and so that's the reason why we added the leap year. Anyways, going a little off topic here. And then we also implemented a day of year, which tells you what day of the year is denoted by the date that you send. Where January 1st would be the first day of the year, and December 31st would be the 356th day of the year, or 357th day of the year for a leap year. So we worked on those a little bit. I had already coded them. I spent a little bit of time explaining them. Now let's actually look at what you're responsible for. So we're going to look at part A here. If you just take a quick look at the problem statement, and I suggest that you do, it's always good, instead of just solely believing what I'm telling you here. But part A, here's part B. I'm assuming part A is here. I don't see part A, but it's number of leap years. And so write the static method number of leap years, which returns the number of leap years between year 1 and year 2 inclusive. There was a comment about what this means, inclusive. It means that you're going to count all the years, all the leap years between year 1 and year 2, all of them, including year 1 and year 2, if they happen to be a leap year. So when I answered this question on the Google document, I gave an example. How many leap years are there between the year 2000 and 2016 inclusive? That means that you include 2000 and 2016 if those themselves are leap years. And I think the answer is something like 6. I might be wrong, but I believe that's what I wrote on my answer to that prompt. Non-inclusive, because that could be non-inclusive, which means that if year 1 and year 2 are leap years, you wouldn't count them. So you don't count the lower and upper bounds for non-inclusive. You do count them for inclusive. So I need to count these. Now, part of the student's question about inclusivity, which was, well, how do you denote that? How do you show whether it's inclusive or not? And the answer to that is that you don't do it explicitly. You don't write, oh, well, inclusive or exclusive or non-inclusive. What you do is you accommodate it in your code within your code. So let's take a look at this method. I'm going to write this one out rather than copy and paste it. It's actually not too hard of a method. Pretty quick. And that's the reason I'm just going to write it out. So let's say we want to look at every year between year 1 and year 2. So I'm going to make a variable called year, and I'm going to start it off at year 1. And let's say that somebody sends year 1, and I'll actually provide an example in a minute, like the year 2000. So year would be 2000. And you say, we can use a while loop or a for loop. I'm thinking I'm going to use a for loop. So I'm going to say while year, not year 1, year, is less than or equal to year 2, perform the following. And all we want to do is we want to check if year is a leap year. So we're going to say if is leap year, which is another question from a document. I'm going to talk about that in a minute. If it's leap year, we want increment count plus plus. I made a variable count. Actually, I'm using a variable count that I have not initialized. So right here I need to say count is 0. So count is going to store my answer. How many leap years are there between year 1 and year 2? Well, whatever the answer is going to be stored in this variable count. Year is a variable that has to change because it's what I'm using to loop in my while loop. So while this condition is true, while year 1 is less than year 2, perform this loop, and then I want to, after the if statement, outside of this if statement, I want to increment year by 1. And then at the very end, I want to return count. I believe this is the entire implementation. Let's talk about it a little more. Okay, so year is going to be 2000. Count is going to be 0. Is 2000 less than, let's make a value here for year 2, maybe 2000, and then maybe 2016. That's year 1, year 2. Is 2000 less than 2016? The answer is yes. So if, and I'm going to send 2000, I'm going to send it to the method is leap year, which we don't have to worry about how it does what it does. We just have to understand what it returns to us. Is leap year returns true if year is a leap year, false otherwise. Okay, so we're saying that when I send the year 2000 to is leap year, if it returns true, increment count by 1. And if it doesn't, well then don't do anything. And then we are going to increase year. So now year is going to be 2001. We're going by 1. 2001 is still less than 2016. And so we're going to say, I'm going to send 2001 to this leap year. The answer is going to be false. 2001 is not a leap year, so I don't increment count. Count stays at 1. And you keep going. The next value that is going to satisfy this condition is going to be 2004. 2004 is still less than 2016. I sent 2004 to its leap year. It's true, and so we increment count by 1. So now there's 2 leap years. The year 2000, 2004, and then we go to 2005. And you're going to do the process. Now, I can count because it's not that many. There's 2000, 2004, 2008. That's 3 already. 2012, that's 4. 2016, that's 5. I believe it's 5. Now I'll test it and check. Now the inclusivity part, inclusive. If I do not put here less than or equal to, instead of I just put less than, that means that I'm going to stop at 2015 because 2015 is less than 2016 and it's not a leap year. And then I'm going to increment year to 2016, and 2016 is not less than 2016. They're equal. And so that would be non-inclusive. We would not include 2016. We would just stop at 2015. So, but I want to include year one, the value year one or year two in my count. If instead of starting year one, year at year one plus year one, instead of I started it at year one plus 1, so say that 2000, year one is 2000, and I said 2000 plus 1 is 2001. This would again make it so that it's non-inclusive of year one. So adding 1 here would make it non-inclusive. Getting rid of that would make it non-inclusive for both bounds. Sometimes you can have one to be inclusive, the other one not. But I want to include the year 2000 and the year 2016, and so I do so by putting this. One last note here, so this should work. I'm going to test it in a minute. But again, the precondition. The precondition says that all my years are going to be greater than 0. So we're not going to have any negative numbers. We don't have to worry about that. And the reason that is something that we should concern ourselves with is because if we have negative numbers, the logic here might not work. Okay? So again, this would break, and we could potentially engage in an infinite loop if the numbers were negative. So we don't have to worry about the numbers being negative. That's what the precondition says. Another also in the precondition, they're saying that year one is always going to be a number less than year 2. So this number is always going to be less than that number. So 2000 is going to be less than 2016. Again, why is that important? Well, because this condition is assuming that when I initialize year to year 1, that number is going to be always less than year 2. And if it's not, we're never going to engage this loop. If it happened that the numbers were reversed, that this number was smaller than this number, we would never enter the loop. But the precondition says always write your code assuming that this condition is always going to be true, that the numbers are going to be positive and that this value is always going to be less than this value. That's what preconditions are for. That's what inclusivity means. So year 1 and year 2 inclusive. Now let's test. I'm going to add a test scenario here. I'm just going to say system.out.print. I want to print what number of leap years returns. So I'm going to copy this. When I send it the year 2000 and the year 2016. Now notice how there's 2 arguments that map to 2 parameters. Right here, there's only 1 parameter, and so that's why I only send it 1 argument, 1 value. Now this should return, by my count, 5 leap years between the years 2000 and 2016, and we get 5. If I put 2020, 2020 is also a leap year, so if I run that, now I should get 6. If I put 2019, then I should only get 5, because obviously I would count all the leap years between the year 2000 and 2019, which is the same as just counting all the leap years between the year 2000 and 2016. Alrighty, let's move on. Now this next part is a little more challenging, and the coding aspect is not hard, but implementation is the functionality, or achieving the functionality, requires some thinking. Day of week. I'm going to pause this just for a minute. Okay, so right here, day of week. Let me first explain what you're being asked to do here. Just like every year, the first day of every year lands on some different day of the week. once again, let me just clarify here. The first day of 2020 lands on a Wednesday, while the first day of 2019, I went up too many. First day of 2019 lands on a Tuesday, so on and so forth. Right here, what they're asking is, okay, well, suppose somebody gives you a date, like March 27th, 2020. So say somebody sends a 3, a 27, and a 2020. And then what this method should return is a number between 0 and 6 that denotes the day of the week that corresponds to March 27, 2020. March 27, 2020 happens to be today, which is a Friday. And a Friday is denoted by the number 5. Here up here, they're telling you how this works. 0 codes for Sunday, 1 codes for Monday, and then all the way until the number 6, there's 7 days in a week, codes for Saturday. And 6 is the last number because we started at 0. And so if you send this method a 3, a 27, and a 2020, it should return the number 5 for Friday, because March 27th, 2020 lands on a Friday, which is the 5th day of a week that starts at 0, 1, 2, 3, 4, 5, 6. And so that's what they're looking for. Let's consider another day, for example, like November 9th, 2020. So November 9th, 2020, that should return, well, what day of the week does that land on? We'd go to November 9th, 2020, and that's a Monday. And so we should return a 1. 0 for a Sunday, 1 Monday, 2 Tuesday, so 1. And so that's what we're after. Now, when you code this, you're not asked to use the methods that you've written, but the whole reason for having these methods that you're not supposed to necessarily, that you're not necessarily, you don't necessarily have to write, but are there available to you so that you can use them. And so the last thing you want to do here is give yourself more work, like start coding stuff without making use of what you have here. You have some methods that could help. Quite a few, 4 of them. And so let's take a look here. Again, this problem is more challenging in the problem solving aspect and not so much in the coding aspect. So I've already worked this out, and it's not the only way to work it out, but I've worked it out, and the code is 4 lines of code, and they're pretty easy 4 lines of code. What takes a little more is to think about this right here. So let me kind of show you what I was thinking, write this out, and then we can talk about it. So I'm going to consider the year 2020 because it's pretty easy to consider. I'm going to consider 2 dates, not just one date. Suppose that we have, well, first let me do here Sunday. Excuse my writing here because I'm trying to make this so that it can write. Here, hold on. I'm gonna detach my keyboard, and so that's easier to write. I'll attach it after I'm done writing on this thing. Hopefully this doesn't take too long. Let me see, where's the pencil? Draw. Erase. Color. Here we go. Okay. Let's increase a little bit here. Okay, so let's start thinking of, okay, Sunday. That's 0. And then Monday is a 1. And then Tuesday, that's 2. And then Wednesday is 3. And then Thursday, 4. Friday is 5. And then finally Saturday is a 6. And so that's how we've coded the days of the week with those numbers. And January 1st happens to land on a Wednesday this year. So here's what color do you guys, well, you guys can't answer this question, but let me just use red, stands out. So Wednesday, in 2020, January 1st is that day. Now I'm gonna look at another day, because I want to code this for one day, and then hopefully that works for all days. The other day I'm going to use for is going to be March 1st, because it's the one that I've been talking about in the videos, 2020. Okay, I ran out of space there, but there we go, 2020. Okay, March 1st, 2020. Now, basically, I know already that March 1st, so in 2020, in January, there's 31 days in January. And then there's 29 days in February for a leap year. And then March 1st is the first day of the week, of that month. I'll abbreviate there. And so if I add all these up, I get the number 61, which is convenient because we have a method that does this for us. There's a method called day of year or something to that extent that returns that value. Now let's think about how that can help us, because we also have a method, first day of year, that returns the number 3 when you give it the year 2020. And so let's think about how we can somehow figure out how to use these two values to get an answer. Now, I'm going to walk you through my thinking. Obviously, this is not the only way to work this out. I want to make sure that I put out that disclaimer there, that it's not the only way. I actually encourage you to figure out how to work this out on your own before you look at the video. But this is what I was thinking. I was thinking, well, I know there's 7 days in a week, so I was thinking of doing something like this. Taking 61 and dividing it by 7. And when I do that, 7 goes into 61 8 times. 7 times 8 is 56. And so 56, to get from 56 to 61, I have to add 5, so a remainder of 5. Again, when I divide 61 by 7, I get 8 with the remainder of 5. And so I was thinking something along these lines. I was thinking, okay, well, 8 weeks, right? I was saying, okay, well, if I have 8 weeks, if from Wednesday the 3rd I go 1 week down, that's still Wednesday, meaning I add 7, and I add another 7, that's still Wednesday. And then I add 7, that's another Wednesday, plus 7 is another Wednesday. That's 4 weeks already. Plus 7, that's Wednesday, plus 7 is another Wednesday, plus 7, that's 3, 4, 7, 8 weeks. So right here we have week 8, which corresponds to this number that I have up here. I mean, right there. 8 weeks. Down from Wednesday the 3rd puts me right here. And then I was thinking something like, well, add 5. So I would add 1 right here, Thursday, Friday, Saturday, and then Sunday, and Monday. That's 5. So I would land on the Monday, meaning to Wednesday the 3rd, if I added 61, which is what I'm adding when I add 8 weeks plus 5 days. If I add 8 weeks plus 5 days, I'm adding the number 61. I get Monday, which is not correct. March 1st lands on a Sunday. So the correct answer is this right here. Right here, this is March 1st. And if you don't believe me, let me pull up the calendar. Hopefully that doesn't mess up here too much, but let's look at, that's not the calendar. There it is, March 1st. It's a Sunday. And so I was thinking, well, I did something wrong. Clearly I did something wrong. And I thought about it and thought about it and I thought about it, and I came up with this. So I'm adding to the day 3 of the week, I'm adding 61. If you do that, it's equivalent to adding 8 weeks. So 8 times 7 is 56 plus 5 is 61. So I'm adding this 3 plus 61, and that's giving me 64. And then I'm thinking, okay, well, 64, if I get the remainder when I divide that by 7, that should give me an answer, but let me not get too ahead of myself. What I found is that I'm already starting at right here. And so I'm counting this number twice. 3 plus 61 is 64. What I need to do is I need to start 1 day beforehand. And then from here, add 61 plus 3. Or I guess I should say 2 plus 61. Now, bear with me. 61 is the number of days in the year starting with January 1st. So March, what did I do here? Okay, March is the 61st day of the year, but that counts the first day of January. It already counts the first day of January. And so when I get 64 here, I'm counting the first day of January twice. I'm counting it right here because it's the third day of the week. It's a Wednesday. And then I'm counting it again in the 61. I'm factoring that in. Basically, what I ended up doing was I ended up subtracting 1 from my count. Now, once again, you could, instead of remainder 5, or instead of, I guess if you want to think of it this way, I could have gone 8 weeks down from Tuesday and then added 5, and I would have landed on Sunday. Or I could subtract 3 minus 1 and gives me 2. And I could have, instead of adding 3 plus 61, I could have added 2 plus 61. And I would get something like 63. And then I realized, wait a minute, 63 is a multiple of 7. And now I noticed this, but I wasn't sure if it was going to work. And so I said, well, actually, it looks to me like I can just add 63 and then get the remainder of 63 when I divide it by 7, which is using the modulus operator. 63 can be evenly divided by 7. I get 0, which is what I'm after. 0 is the answer I want. And so I think I ran into the answer without realizing that I had run into the answer. Now, I started asking myself, what's the biggest number I can get from this? If I take the number 63, or any number for that matter, and I get the remainder when I divide by 7. And the biggest number I can get is the number 6. That's the biggest number I can get. Which gave me some confidence, because that's the biggest number I want. And so I believe, in trying to work this out, I kind of stumbled upon the right way. I feel like I was on the right track, but I feel like I did somewhat stumble on it. So let's try it out. Let's first start here by logging the first day of the year. So int, I'll call it first day. I don't want to call it first day of year because there's a method by that name and I don't want to confuse you. So I'll call here first day and then year like that. Equals what the method first day of year, which is up here, first day of year, returns when I send it the year. Now I can only send a year between the year 2000 and 2020. That's it for now. But it's okay because I'm trying to test this. And I'm just going to test right now for the year 2020. So 2020. Now clearly I'm hard coding this and I don't want to hard code this. Instead, I'm going to take whatever month, whatever the value of this parameter is. I'm not month. I'm going to take the value of year and place it there. So first day of year. Now, if the year is 2020, this is going to return a 3 because January 1st, 2020 is a Wednesday. Good, okay. I want to add that to the day of the year, which is returned by this method. And so I'm still kind of sticking with March 1st, 2020. That's my test case. I want to try that. But I'm going to copy the heading here. I'm going to say here, int, I'm going to call this just day equals day of year. And I can send it March 1st, 2020. But again, I'd be hard coding this. I forgot a semicolon here. I don't want to hard code this. Instead, I'm going to send the parameters month, whatever that is. I'm going to send that. I'm going to send day, whatever that is. And I'm going to send year, whatever that is. Good. And then, so I did basically the math I have done here, which is basically add the day of the year. For March 1st, that would be the 61st day of the year, to the first day of the year. In this case, the number 3 for a Wednesday. But I need to subtract 1 to go 2. And then whatever I get from that, I need to get its remainder when I divide it by 7. So that can be all one operation, which I'm not going to do. I'm not going to put into a new variable. I'm just going to do it here. I'm going to put parentheses, modulus 7. And then I'm going to put here, let's add first day of the year plus the current day minus 1. And I'm going to get the remainder of that when I divided that by 7. And I think this is it. Now, the only way to find out is to test. And it's just easy because we have a calendar with us. Int day variable and is defined. Oh, I cannot use day because it's already the name of the parameter. So I'll call this day of year. Let's test this. Obviously, it returns an integer, day of the week. So I need to print that. And I have a method that prints, or I have a method where I can run this code. I forgot the print statement. So I'm just going to copy this. And I'm going to send it March 1st, because I know what March 1st, well, that's what I was looking at. I'll test the other ones. I want to know what day of the week March 1st, 2020 landed on. If I get a 0, that's Sunday. If I get a 1, Monday, so on and so forth. Let's run this. 0. So it's saying, and I can comment these out if you don't want to see them, Control / comments that out. So we don't confuse our answers there. A 0. That's saying that the 0 stands for a Sunday. That's saying that March 1st, 2020 landed on a Sunday. Let's take a quick look. March 1st, 2020. It works. Okay. Let's try another number or another value. Let's do July 4th. That would be, July is the 7th month, 4th, 2020. 6 is a Saturday. Let's take a quick look. There it is, Saturday. Good. So let's try December 12, December 31st. I know that is always a nice day. Okay, especially in this year, right? That's 4. That should be a Thursday. Let's see. Oh, there it is. Thursday. Good, it's working. Now 2020 is a leap year. Let's try a year that's not a leap year. Let's try 2019. And let's look at, what's a good day? September 5th. I'm gonna have you guessing on what these dates are, but September 5th. And I'm really hoping this is gonna work. 4, that's also a Thursday. Let's look at September 5th, 2019. Here's September, Thursday. So that works. Now, I will say that my explanation may have been somewhat rushed right here. But I encourage you to think about what I did. If you have questions, please ask your questions. You know where to reach me. And that does it for this video.